Hello, this is not your chem tutor, and in this video, I will be teaching you Boyle's Law under the topic of ideal gas laws. So in this video, I will share 4 examples so you can practice some calculations. Let's discuss a little bit of concepts. According to Boyle's law, at constant temperature and fixed amount of the gas, pressure is inversely proportional to volume. So again, pressure is inversely proportional to volume. So what do you mean by inversely proportional? That means when you increase the volume, the pressure will decrease. On the other hand, if you decrease the volume, the pressure will increase. That's what you mean by inversely proportional. And you can see this in the graph shown in the screen. As you can see, if you increase the volume, the pressure drops or the pressure decreases. So that's what you mean by, that's the simple concept of Boyle's law. In solving problems about Boyle's law, there's one formula you need to familiarize, and that is P1V1 equal to P2V2. So let's define the variables. P1 is initial pressure. V1 is initial volume. P2 is final pressure. And V2 is final volume. Also, I want you to take note that the formula for Boyle's law is not strict in terms of unit. So you can use any unit of pressure you like or any unit of volume you like as long as you are consistent in using that unit. So what do I mean by consistent? If you use, for example, atmosphere as the unit for P1, make sure that you are also using atmosphere as the unit for P2. If you are using kilopascal for P1, then use kilopascal for P2. Same with volume. If you use liters for V1, make sure you use liters for V2. If you use ml for V1, make sure you are using ml for V2. So just be consistent with your units. Let's try answering example 1. A gas occupies 240 ml at 1.25 atmosphere. What will be the pressure if the gas expands to 320 ml? So this is a Boyle's law problem, so you will be using this formula. So let's assign the variables. 240 ml is your initial volume or V1. 1.25 ml is your initial pressure or P1. And 320 ml is your final volume or your V2. So let's substitute these numbers in the equation. P1 is 1.25 atm. V1 is 240 ml. That is equal to P2, which is unknown, times V2, which is 320 ml. So to solve for P2, you divide both sides of the equation by 320 ml. So 320 ml cancels on the right side. And what is left on the right side is P2. And on the left side, ml will cancel. So the unit would be atm. And if you solve this in your calculator, 1.25 times 240 divided by 320, this is equal to 0.9375 atm. And this is the answer to the question. For example 2, the pressure inside a 1.5-liter balloon is 2.60 atm. If the pressure is increased to 3.00 atm, what will be the volume of the balloon? So 1.5 liters is your V1, 2.60 atm is P1, and 3.00 atm is P2. So we have P1, 2.60 atm, times V1, 1.5 liters. That is equal to P2, which is 3.00 atm, times V2, which is missing. So to solve for V2, divide both sides of the equation by 3.00 atm. On the right side, 3.00 atm will cancel. So what is left on the right side is V2. And on the left side, atm will cancel. So the remaining unit would be liters. And if you solve this in your calculator, 2.60 times 1.5 divided by 3, this is equal to 1.3 liters. And this is the answer to the question. Example 3, when a balloon expands to 4 times its original volume, what happens to the pressure inside the balloon? So if you read the problem, the first part says a balloon expands to 4 times its original volume. Therefore, the final volume, or V2, is 4 times its initial volume. So 4 times V1. Now let's use the Boyle's Law equation. P1 V1 equals P2 V2. So P1 V1 equal to P2, and we know that V2 is 4 times the original volume, which is V1. So what to do next? You can divide both sides of the equation by V1. So V1 will cancel. On the left side, what remains on the left side is P1. And on the right side, V1 also cancels out. So what remains on the right side is 4 P2. If you divide both sides of the equation by 4, 4 will cancel on the right side, and what is left on the right side is P2. And on the left side, you have P1 over 4, or 1/4 P1. So what does this mean? This means the pressure decreases to 1/4 of the original pressure. And that is the answer to the question. For the last example, please refer to the illustration. So we have container A holds 800 ml of gas at 3 atmosphere, and container B holds 100 ml of gas at 5 atmosphere. As you can see, the two containers are separated by a stopper. Now, if you remove the stopper or you open the stopper, the gases will mix. Now, if the gases will mix, the question is, what is the resulting pressure? So if the gases will mix, the first thing we need to do is to compute for the total volume, or V total. So container A is 800 ml plus container B is 100 ml. So when the gases mix, the total volume is 900 ml. So for this problem, what you need to do is to perform 2 P1V1 equals P2V2. So you do it for gas A and gas B. So let's start with gas A. P1 of gas A is 3 atm. V1 is 800 ml equal to P2, which is unknown, and V2, the total volume, is 900 ml. So to solve for P2, you divide both sides by 900 ml. So 900 ml cancels on the right side. So what remains on the right side is P2. And on the left side, ml will cancel. And what remains is atm as the unit. So 3 times 800 divided by 900, that is equal to 2.67 atm. So the pressure of gas A after mixing is 2.67 atm. Now let's do the same for gas B. The initial pressure of gas B is 5 atm. And the volume, initial volume of gas B is 100 ml equal to P2 times the total volume, which is 900 ml. So divide both sides by 900 ml. So 900 ml cancels on the right side. What remains on the right side is P2. And on the left side, ml will cancel. What remains is atm. So 5 times 100 divided by 900. So the final pressure of gas B after mixing is 0.556 atm. But the question is asking for the resulting pressure. When you say resulting pressure, that will be the total pressure of gas A and gas B. So we know by Dalton's law of partial pressure that the total pressure is equal to the sum of the individual pressures. So in this case, the total pressure is the pressure of gas A plus the pressure of gas B after mixing. So P total is equal to 2.67 atm plus 0.556 atm. And if you solve that in your calculator, this is equal to 3.226 atm. And this is the final answer to example 4.